Welcome to episode 3 of How Can I Store a Code Snippet in a Struct? Episode 1 was with function pointers. Episode 2 was unboxed closures. Here, in episode 3, we're going to do it with a boxed trait object. For context, I'm going through this Stack Overflow answer, which is awesome, and using each strategy to give aliens in a shooting game different ways of recovering when they've been hit. The thing I learned in episode 2 is that you really have to understand an example to follow it. Here's the example for this episode. This is the struct that contains the code snippet, and this field is a boxed trait object. I think we need to define that. A trait object is something from a type that implements the trait, but here we've erased its original type. We don't care what its original type is, we only care that it has implemented our trait. But what is our trait in this example? Fn is a trait. In this case, it's a function that takes a useSize parameter and returns a useSize value. That args parameter is actually a tuple, so you can pass multiple things into it. Our field is a box that contains a trait object. The dyn means that the actual type varies, but this code doesn't care what the original type is. It only cares that it implements the Fn trait. This is really key. Remember, in episode 2, we learned that every closure gets its own type, so we can't make the box generic to the actual type and pass closures into it. That's why we're essentially erasing the closure's type with that dyn. In the implementation of that struct, he's built a new that takes the trait object and wraps it in a box to store it in that field. The only magic here is that plus single quote static thing. That's adding a lifetime restriction on the type of the closure. I've spent a couple of days pondering what that static means. The definition I kept finding was the data pointed to by the reference lives for the remaining lifetime of the program. Well, that makes no sense here, because we certainly don't want every closure we store this way to lay in memory forever. It turns out there are two static lifetimes. The first is if it's attached to a reference. That means that the data being referenced lives for the remaining lifetime of the program, though we can force it to be shorter. The other is if it's attached to a trait, then it's called a trait bound, and it means that the type, in our case, the original type of our trait object, will only contain static references. So this example is using the second definition, and essentially, that quote static is making sure that anything referenced by our trait object will be around for as long as our struct exists. That's critical to being sure that the trait object will be valid when we use it. Given that struct, there are two ways we can create foo objects. We can build it explicitly and put the box around our closure ourselves, or we can use that new method, which will box it for us. In case all of the foos are confusing, let me color code them to make sure the example is clear. Now that we understand the example, let's go take our alien recovery code and modify it to use this strategy. This is the code from episode 2 that has the unboxed closures in them. I'm going to start by changing, so I still have the recoverable attributes are separate. It is the alien struct that I'm changing. And when I change it to be a boxed trait object, it does not need to be a generic. And the type of this is going to be a box. The dyn function takes recoverable attributes and doesn't return anything. So then the constructor is going to not have a type. And it's going to not need this because it doesn't have generic on it. And its recovery behavior is going to be something that implements an FN recoverable attribute that is static. And then for the recovery behavior, we're going to have to put the box around that. Okay. And now to call it, we're going to have to unwrap it. That's not what we want. The type mismatch. So this function ought to take mutable, one of those. And this one should take mutable, one of those. All right. Okay, so I think that's the change in how we set things up. I don't need, when I am implementing debug for alien, type. Okay, so then all I need to do down here, this is not going to work. I need to pass into, so when I create him, this is calling this, and it has to implement fn mute of a, oh, let's get rid of trying to capture things for the moment, because I'm not sure why I can't do that, but let's like simplify the problem first. Okay, that looks like it works. So then the only question is, why could I not capture? When I did this, expects fn, but this is an fn mute because now I'm changing something that is not what I passed into it. So when I was not capturing recovery strength, the closure could be an fn that you can, because it was not changing anything that it captured and it wasn't giving ownership of anything to anybody else. But now it is changing the value of recovery strength. So that would mean that I would need to make these be fn mute. Closure may outlive the current function, but it borrows recovery strength. Okay. So it's saying, so what is worried about here is I have passed in a closure that has captured recovery strength, but it's captured a borrowed mutable version of it. It doesn't own it. And so it's afraid that Mighty Max could exist longer than the function that we're in. And then that closure would still need recovery strength, even though recovery strength had gone away. So if we're going to do this, then we have to say move. Oh, that's not where to put it. I did it wrong again. Move. Then I can do this. So, oh, and I need to put this back too. Yeah, so now he recovers 5 and then he recovers 4. And once I have moved it in there, do I ever get it back? Oh, because I've moved it in there, I have my own copy and he has his own copy. So yeah, I still have a recovery strength. Mighty Max has his own and he's decrementing it. So in order to do this way, I had to move it in because this was not static. Is there a way to make that static? Okay, it's saying that what I'm trying to do here, where I'm trying to give it a recovery strength and still be able to hold on to that recovery strength, so I don't want to do the move. It really doesn't want to let me do that. And the reason it doesn't want to let me do that is because now I can change it and he can change it, and that would be unsafe. And I don't want to do things that are unsafe. There must be another piece that I need to learn to make this happen. But for now, let's say that we do the move and we put this back to there we go. Okay, so that is the boxed trait object version. When I modified it to capture something that it was going to change, I also had to change it to FN mute instead of just FN. And I've had to make it move recovery strength into there. And I'm not sure why. Oh, and the reason that I cannot do that this time, but I could do that with the unbox closure object, is because box is really afraid. When I do this box, it's really afraid that this thing is going to go away while it's got a pointer to it, a reference to it. And so that's why I had to put this static there. That is what makes it so that I can't share the object the way I shared the object in the unboxed version. But the nice thing about the box version is you can see down here, I can now put both Fred and Mighty Max into the same list because they have the same type. Because we didn't have to put the generic on it, because instead of storing the closure naked, we've stored it inside a box. So all of the aliens are of exactly the same type, and therefore we can put them together in a list, and I could run around every tick and tell each one of them to recover. That's episode 3. Now I'll go work on the last one, episode 4, where we're going to do trait object references. Fascinating.